So today we're going to be maybe starting our waves. So right now we've got wave 1. At the beginning of wave 1 it needs to come up, it needs to say wave 1 and then we spawn all our bad guys. But I'm not going to do that just yet, because if we do wave 1 right now, anytime we play and want to test our vultures, we have to wait for that wave 1 to get initialized and then spawn everybody. So I think what I'm going to do is work on wave 2. That way we can hurry up and kill vultures and make sure wave 2 is working. I just don't want to have to wait through wave 1 every single time. But we can take a look at our notes and see. Oh, yeah, we found a bug yesterday. Ugh. That's a tough one. Let's see if I can show that. It's so hard because I need to kill a vulture going this way, and it needs to be about right here coming left, and I need to kill it. Which is out of our control to make happen at the moment. It's so hard to test that. I guess we could just spawn a oh, here we go. Well, it's really tough. Oh, it's really tough to test. We could manually spawn one there. We'd have to overwrite some stuff. I don't know if we should tackle this right now or... Oh, that's exactly what we need. That's exactly what we need to test. So watch the vulture here. So let's see if it gets the jockey. See, it doesn't. That's exactly what we're trying to fix. Now, it misses it. See, look, why does it looks like its Y position gets higher as soon as it becomes ungrounded, but that shouldn't be the case. I feel like it might be jumping. Which is why the Y gets higher. I was thinking that it just had its height shrink because it was ungrounded, so it was a square instead of that tall rectangle. But it looks like it's actually jumping as soon as it's there. But it shouldn't be jumping because our Y is actually smaller than our jockey Y, so is it the only time we jump? So I guess what we could do is make our jump half as strong but twice as often, or 3 times as strong and 3 times as strong and 3 times less often is a potential way to see if we could possibly fix that. It'll just be hard to get that scenario to test it again, but let's see if we can tweak something like that. It's actually in our taxi class. So if we need to jump, we jump a 0.6, so let's half that. So we only jump a 0.3, but we do it twice as often, or actually this would be 0.05. Yeah, because it jumps sooner. So now the taxis should flap That's exactly what we need to do. This is perfect. Yes. We'll see. We'll see now. I'll see. Okay. So yeah, they're jumping a little less. Okay. Well. Nice. That's perfect. That's perfect. That's exactly what we want. So let's watch. Let's see if it gets it now. Nope. Well, it does get it. It just got it by bouncing. Yeah, it needs to jump higher. It needs to jump higher. Now the flap counter, we become unflapped. We become unflapped if our self-flap counter is smaller than 0. We decrement this flap counter, so the higher this number is, the longer it takes to become unflapped, which means it doesn't have anything to do with our needs to jump, actually. It just has to do with how long our downwards flap sprite is on. So maybe this is actually better to be like a 4.5 or something, 0.45. But when does needs to jump get true? Only if our y is bigger. Okay. Let's see, because I think there's one, we might need to also say only become flap true if we're not already needs to jump, because we don't want to necessarily increment our dy in 2 frames in succession, so we might need to tweak something there, but we'll try to see. Dang it, that was perfect. That was what I needed. Fly, 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 fly. Yeah. We could just pick like, hey, Vulture 3, you know, spawn at a top, spawn at that right platform spawn point every time. Here we go. Perfect. Okay. Let's see what happens with the taxi now. We should jump a little higher than we used to, but a little less than our last commit. It worked. It worked and the animation looked fine. So do we call it? Do we call that being okay? We fixed the known bug. This is so cool. It worked. We fixed it. Because it was only missing it by just a small margin. That was a bouncy egg, yo. Okay, well, I think that fixed it. We replicated it once and it fixed it and the animation looked fine, so we're going to tentatively call that fixed, and if we need to come back and do it, come back and fix it, we always can. Now if there's 2 taxis that spawn in a similar time, sometimes their animations get synced with one another, and I don't know why that would be happening. So I don't know how to exactly recreate that bug, but I have seen it. So if we see it again, we might be able to review the footage and see what caused that, and then maybe we can debug it a bit, but it's hard for me to find and debug that at the moment. We also need to add wave 2 text. We need to add wave 2 spawns. We need to, I think the lava level rises after wave 2. I think it rises okay, so I believe we have this, we count any vulture that's still alive, and we put it in our, what is it? Vulture. We have a vulture count, I know, in our play state. I thought it was called vulture count or something like that. I'm just not seeing that. Oh, vulture count. That's exactly what it is. Vulture count. If we take a look at what we're doing for that, we're saying, we shouldn't need to initialize it to 0 here, actually, because we init it at 0, but we're cycling through every vulture in our vultures table, and if we're not exploded, we count it. We add it to the count. So actually, we need to reset the count here, actually. Vulture count gets 0 so that we don't count way more than we have, because this will run every single frame and count our vultures, so we need a count at 0. And then by the time, you know, after we've done all of this, then then if our vulture count is equal to 0, meaning all vultures are exploded, and exploded only happens once we kill them and send them to the graveyard, but actually that's not the case. We need to check if each egg is collected, because just because we kill the vulture doesn't mean we spawn the new wave. So we actually need to worry about our egg collected, which, let's take a look at our egg class. We should have it collected. We do. So look, let's see what our dot collected is. When do we set that to true? We'd probably do it in the play state here. So yeah, we change our collected to true if our player collides with that egg and it was not invulnerable and it wasn't already collected. So yeah, that's what we need instead of the vultures. We need to cycle through all our eggs, and if all of our eggs for that given wave are collected, then we go ahead and increment our wave. So we need some sort of system to do that. Oy. Okay, hold on. I need to... I don't remember how to open a new Tmux tab. New window. What is the shortcut for that? So it's the leader key and then C? No, it's I want a split tab is what I want. Let me see this. Yeah, how do I split the pane? That's what it is. How do you split the pane? Vertical layout is the quote. So let's do control and then our quote. Cool. Config. I'm looking for my NeoVim shortcut de-highlight stuff. Leader NM. Okay. Well. That's not what I wanted to do. I've got to learn Tmux better, but I just opened a new tab. Yeah, I gotta learn Tmux better. So we have something highlighted to get rid of it, leader NM, and then got rid of it. Okay. Where were we? We need some sort of system to trigger our waves, right? So like, we need a list of all the waves and say, you know, wave 1 gets true upon initialization, but all the others are false. And then if it's wave 1, then we know we need to cycle through, you know, we need a variable that gets set on which wave we're at that determines how many global object tables we need for each enemy. Because each enemy needs a vulture, an egg, a jockey, and a taxi. It needs all of those things. So wave 1, global enemy table, whatever we want to call that number, is going to be 3. Wave 2 is 4. We'll have to do research on what the other ones are, but we need to do some sort of workflow to say, you know, we init in wave 1. If it's wave 1 and wave 1 global objects, that number, if all of those variables, all of those eggs dot collected are true, then we go ahead and wave 1 gets false, wave 2 gets true. And then if it's wave 2, we populate all 4 items, all 4 global tables in our enemy global table, whatever you want to call it. And then we populate with dummy values initially, and then we spawn at the random spawn points, just like we're doing for our current wave 1. So we'll have to do something with that. So let's just give us these variables in our play state, and then we'll call it a day because I'm about to fall asleep. But we'll probably actually implement it tomorrow. But we need like a you know, wave 1 gets true upon a knit, whereas wave 2 would get false. Wave 3 would get false. We need to track, we need to see how many waves we actually get. And then we need to do something like we need a number, we need a variable to store the amount of enemy objects we need every wave. So we can either overwrite that number anytime we switch a wave, which is probably the way to do it. That way we don't accidentally, well, we could do this differently too. We can say wave, actually, yeah, let me see. Wave, we do have a wave variable that's already getting set to 1 somewhere. Yeah, so we initialize wave to 1. Okay, so we've already got, we don't actually need this. So instead, we can do, you know, if wave is equal to 1, then, and then we can say, 3, enemy global tables, but right now we're hard coding in the 3 for this wave 1. So we need to switch all these for loops to not be 3, but to be a variable that on wave 1 is 3, but if wave 1 is 3, then we would say, you know, we would call it enemy objects, because each enemy object needs the same amount of other objects to be paired with it. So we could say enemy objects gets 3. So now when we're in wave 1, when we replace all these 3s with our enemy objects in wave 1, it'll just do, yep, it'll only do 3, and then we don't, this is tough, but we can do something like this, and we don't need a bunch of variables. We just have our one wave variable, and then we can say what am I doing wrong? Okay. So we can do something like this, where instead of doing this every single frame, we can do this for our if our wave 1 score populate is not true. Now we had to do this because the way this, it's been so long since I looked at this, but I guess we do lowest egg score gets lowest egg score plus 250. I'm not sure what's actually happening here. So we've got a scores table that we put in a print score object. Let's take a look at our print score object real quick. Here. So our print score object is what we're using to print the scores whenever we collect an egg. So it's got an X and a Y position, and it's got a score amount, and it's got a flag for being a double score or not, and a timer so that we can unrender it. So what we're doing here is we're inserting into our scores table a print score object for every enemy object we need for wave 1. But then we're saying lowest egg score. See, I don't know what this is actually doing here. Lowest egg score is adding 250. I don't know what we're doing here. Because we set lowest egg score to be 250, and then we add 250 per every... I don't get why we're doing this. Oh, because we're inserting... Okay. We're inserting our lowest egg score into our score amount for our print score tables. So our print score tables are the one thing that aren't tethered to the enemy object global tables, because you can kill any enemy in any order, and the score is determined by the order in which you kill. See, this isn't exactly right. This is a good start. I say incremented by bounder score because, yeah, this is tricky. This is the right logic if everything is a bounder score, but we need to do something better than this, because we need to be able to determine, hey, by the time we kill an enemy, what tier is it? That'll give us our score. And it's also dependent on how the original did the scoring as well, which is tough to test. So I'm gonna add some homework for me, which is to research how scores are calculated in original. And then once we have our heads wrapped around that, we'll know how to implement it, because right now we're just kind of shooting in the dark with like the lowest egg score. Because it's kind of like the first egg you get is 250, the next egg you get is 500, and then 750, something like that. But you also get a base amount of points for killing the different vulture tiers. So I'll need to figure that out. We didn't do much at all today, but we did fix the bug from yesterday, which is nice. And then we're starting to visualize how we need to spawn these enemies based on the waves, which involves spawning all of our enemy objects and all their corresponding enemy objects into their appropriate tables, depending on the wave. But then we need to dive a little deeper and make sure that we are giving the right score amounts, because there's one more factor to every wave. It's not just populating the right amount of enemy objects and corresponding enemy object table values, but we also need to populate our print score objects, which is something that can easily be slipped by, but we found it, so we need to make sure to include that in our wave logic generation. And once we've got that figured out, it'll be easier to say, okay, if wave 2 give us the wave 2 amount of enemy objects and the wave 2 amount of print score objects, and then we need to figure out the bonus points for, depending on which tier of vulture you collide with, modifies your base points, but then there's egg points as well. So you get a certain amount of points for killing, and you get a certain amount of egg points for collecting. And that could vary between collecting eggs or collecting jockeys. I don't exactly know yet, but that's part of my homework. We did fix that bug we found yesterday though, so that's good. So I'll catch you guys tomorrow, and we'll hopefully have a better idea of how to generate these print score objects so that we can handle wave 2 logic. And then it'll start to feel like a real game, because once you kill all 3 from wave 1, you get wave 2, and then, that'll start to feel like a real game.